Hello, everyone. My name is Nia, and welcome to today's webinar. We'd like to give everyone a minute to join and settle in. Please use the chat to let us know where you're tuning in from. I myself am tuning in from New York City, and we have Apurva, who is joining us from San Francisco on the call as well, who will be answering all your questions in the Q&A. Make sure when you are putting where you are tuning in from, you're putting to everyone, because there may be someone in the chat that's watching this webinar and they're in the same location as you. So when you respond, making sure you put to everyone. And I see someone from Vietnam, Germany, Syracuse, New York. So looking forward to seeing the global audience come in. Argentina, Morocco. Make sure you're responding to everyone in the chat because there may be someone in the same location as you. Hello from Kenya, India, Iceland. Wow, I haven't seen that one. Canada, Florida. Hello from the Sunshine State. India, from Spain, Argentina. We have a lot of people from India. Thank you for joining us. I know it's late your time, so anybody that is joining us later in the day or really early in the morning, we do thank you for taking the time out to join us for this webinar and engage with us. Someone from Los Angeles. And we have Apurva, as I said earlier, who is in San Francisco from the West Coast as well. So early morning to you all. Antarctica. That's the first time I've seen that. I hope someone else is in the chat from Antarctica. But it does look like we have a good amount of people, so I'm going to go ahead and get started. So again, I'm happy to welcome you all to today's webinar, Expanding LLM Applications from RAG to Agentic Systems. In today's presentation, we have Staff Developer Advocate Richmond Alake. And answering all your questions in the Q&A today, we have Apurva, our Senior AI Developer Advocate. But before we jump into today's presentation, I'm going to go over these housekeeping notes. The webinar recording will be shared. All participants will be muted. So if you do have any questions, please drop them in the Q&A box at the bottom of your Zoom panel. It'll say Q&A, and it'll be a question mark with a box at the top. So make sure you're dropping all your questions in there for Apurva to answer live throughout this presentation. There will also be a short survey at the end, so please make sure you take some time to fill that out before you leave today's webinar. Now on to today's presentation.
Thanks a lot, guys, for joining me today. I see a lot of people from all over the globe. Today, we're going to be covering LLM applications in general, but we're also going to be looking at the two common form factors people are talking today, which is RAG and also agentic systems. But we'll start off with some overview of MongoDB. And most folks recognize MongoDB as a database company. But MongoDB is a developer database platform offering MongoDB Atlas, which offers the MongoDB database as a cloud service. And within our platform, we have other functionalities and features, such as the MongoDB charts, Atlas Edge, triggers and stream processing, and many more. And within MongoDB, we are storing data using the familiar JSON schema, but an extension of the JSON schema, which is called binary JSON. And essentially, this data model allows familiarity with the way we transport data across the application stack. So every developer, regardless of programming languages, is very familiar with what a JSON schema looks like. And we bring that mentality, that mindset into the data layer. And that allows you to build AI and LLM applications. And within RAG, you might use MongoDB as your vector database. And today we'll be seeing MongoDB being used as a memory provider within agentic systems. So this is what that JSON schema looks like. And just to give people an understanding, and you can store this data within MongoDB just as it is. Before we move to any code, there will be loads of code sharing in this webinar. I want to talk about the form factor evolution that we've seen in just a very short amount of time. We started off with LLM powered chatbots when ChatGPT came out. Essentially, we got access to utilize the parametric knowledge of GPTs to answer very simple queries that we provided through the chat interface. Then we moved into supplementing the queries with some relevant information, some relevant data. And that is essentially the RAG design patterns. Then we started to build up this LLMs and increase the number of parameters, and emergent abilities started to arrive within the scene, such as tool use and also advanced reasoning and planning, which allows us to go into the realm of AI agents and agentic systems. So we'll be covering RAG and agentic systems and what AI agents are today, both at the definition level and the implementation level as well. But before we start to go deep, we're going to talk about the AI stack in general. I believe it's always good for people operating in this space to have an understanding of the tools we're playing with and how we visualize the space itself. So very simply, the AI stack combines a bunch of tools and technologies together to create an AI application. And this could be your LLM frameworks, your vector databases, evaluation and monitoring tools. You can look at the AI stack from two different levels. I see it at the eye level, where you have the application layer, the tooling layer, and the compute layer. So the compute layer, you have the folks like NVIDIA, this is where they reside. And in the tooling layer is where you see MongoDB enabling developers like yourself to build applications, AI applications. But if you double click into the AI stack, you can expand the view, the stack, to give a more in-depth understanding of what's really going on when we're building AI application. The programming languages are things that we should be considering. Python is a dominant language used to build some of this AI application, and JavaScript and TypeScript are very close as well. But there are other programming languages emerging where you can see LLM orchestrators and frameworks that are being built in. So Java, C# as well. But when you look at the stack this way, you start to understand how tools come together to essentially build your AI application. So what is RAG? RAG is a design pattern that emerged, well, it's not relatively new, but it's emerged essentially to supplement a user query passed into an LLM with relevant data. So this data could be domain-specific data, proprietary data, or data from anywhere, but essentially is using the parametric knowledge of the language model and the non-parametric knowledge, which could be any data from any data source, to respond to a query. So for example, this is what we did in the beginning. We got access to ChatGPT and we said, hey, give us some recommendations for my next holiday. Person A and person B probably got the same recommendation. Tokyo, and an example of a response would be, Tokyo, Japan is a popular holiday destination. It is one of the most visited places this year. And you can also consider London in United Kingdom. This is just my bias creeping into this presentation. But when you start to bring in relevant data or start to explore RAG, what you actually can get from this LLM is more personalized response. So we pass in some data, some relevant data, add it as additional context to this same query, and now the response is more grounded. It's more relevant to the user. So hi, Jane, we're able to get that from the document that was passed in as additional context. We're able to get that this person is Jane, able to understand the type of trip she likes, and also provide some of the specific requirements that Jane requires. So this is a very simplistic overview of how RAG works, but we'll dive into more detail. But the key aspect is retrieving relevant data, and there are different ways you can do it. Vector search is very popular. You can use typical lexical keyword search, or combine both, and you get the hybrid search functionality. So what I'm going to do is just go over some aspects of what a typical RAG pipeline will look like. And those of you that are in the weeds of building RAG pipelines, you would know that each of this box here, you can double click into it and spend a month exploring different ways to optimize each of this layer or process within this pipeline. But generally, we start off with data sources, right? This can be existing databases, repositories, or data set, web pages, or APIs. And you ingest your data into your environment and you go through some data preparation. Now, most folks are familiar with this step. This is typically data science, right? Data analysis, data science. And the topics you want to be considering here are things like data quality and data pre-processing techniques. So once we get our raw data, we prepare our data, we chunk our data as well, and we embed those chunks to get a vector representation of the data object that we've passed in. And alongside with the metadata, we can ingest these data objects into MongoDB. And what that enables is for an application user to make a prompt, and we essentially vectorize that prompt and retrieve embeddings, vector embeddings in our database similar to the query vector. And then we're able to retrieve documents that are similar, and then we can essentially provide that provide that into the context window of the large language model, which can then return a more relevant response. So that is very quickly in a nutshell a RAG pipeline, how it essentially works. And you can go into of this processes and optimize and explore in different dimensions. But we'll see a very typical flow, implementation flow of a RAG pipeline alongside an implementation of what an agentic system will look like. And we're going to be building this agentic system using LangGraph. So some of you might be aware of LangGraph. It's built by the teams in LangChain. But before we dive into any implementation code, it's good to understand some terminologies that are floating around. AI agents, agentic systems, agentic workflows. So just to concretely put it, the way I understand AI agent, and I say that with a caveat, which is the way I understand it is because this space is emerging so quickly. There isn't a textbook definitions for AI agents, but everyone is trying to understand things in the best way. But AI agents essentially are computational entities that have awareness of environment, ability to perceive the environment, which could be through inputs such as text or images, but can also conduct actions through tool use and have cognitive abilities such as reasoning and planning. And also AI agents have some form of memory, either short-term or long-term. So this is what I understand AI agents are. They're autonomous, they're independent. But then I'm a very simple person. So I just visualize, you can imagine this as a very simple LLM. Then an agent is, you're giving it more capabilities to be able to act independently, to give it more sort of characteristics you would see from let's say a human counterpart or a human professional. Then you go into the realm of agentic system. And I was discussing this with the team earlier. Sometimes you might use both terms interchangeably, and people do. AI agents, agentic systems, agentic AI. When I talk about agentic system, I'm really looking at a broader overview of the architecture that an AI agent, so multiple agents might reside within, and they would have access to various parts of the system and have the ability to call on different system components at various times to achieve an objective. So they have access to utilize various system components and resources. So this is when you're talking about agentic systems. So here is a more expansive visualization of what an agentic system might look like. And here you can see the typical process that we have of data loading and ingestion. And this is the same for RAG or pretty much most process that involves data, most data intensive application. You go through a data ingestion and loading process. But the key thing about an agentic system is you can have RAG incorporated as well, but you're using the RAG capabilities, the retrieval capability as a tool for the agent to use based on its discretion. So what we're essentially doing here within an agentic system, or the key characteristics of agents, are they have tool use, an advanced LLM that could at least conduct reasoning and planning for task decomposition. Then based on the decomposition of the task, they can apply the available tools to solve certain parts of the task they've decomposed. And an AI agent, unlike the chat interface we're used to today, does not operate with a back and forth conversation like, well, it can sometimes, but it doesn't generally operate with back and forth conversation like you see in chat interfaces. Essentially, these are objective driven systems where you can give an objective or a certain outcome, and with the tools that are available to this agentic system, they would focus on utilizing those tools to achieve the objective. So it will run in a loop, essentially, passing the output of a previous iteration as input into the next. So that is, in a nutshell, how I visualize or talk about agentic system. But generally, when I start to think about definitions and diagrams, I feel like it's better to work backwards. And what I mean by that is go out and build these systems and see how they work. Then you can then work backwards and compress the understanding into definitions or terms. That is the best way, because this space is basically evolving very fast. So we can bring things to more a MongoDB perspective, and where does MongoDB fit within the agentic system? You can understand MongoDB as a memory provider within agentic system. So agents need memory, different forms of memory, the same way humans need memory. So humans have short-term, long-term memory over various type of memory that is way beyond me. But if you just take this concept and apply it to an AI agent, you realize the importance of a system like or a system component like MongoDB, which is memory enables agent to be able to improve by looking back at previous iterations or previous executions of operations and learning and adapting. Also adapting to different entities that they might encounter. So in this code session, I'll be showing you how you can use MongoDB as a knowledge base, as a profiler, as a toolbox, as a data store, as a working memory, all different flavors of memory that are required within a agentic system to improve the chances of building a successful application. So on that note, we can actually go into the code. Like I said, this is going to be a short presentation, but very code heavy. So we have the same RAG pipeline visualization here. And I'll go through this, and I'll be very cautious of time as well. But we go through the steps of installing the packages. In this particular use case, I created a data set for that essentially could replicate a scenario for an asset management analyst. And this particular asset management analyst assistant is going to have a knowledge base that allows it to conduct market, that has it has access to market reports of some tech companies. And these are all fake tech companies, synthetic data that I generated. So these are not real companies. So I'll take you through the step of how we load the data, essentially prepare the data itself, create embedding, then ingest it. Then we can use vector search. I'll take you through all up to this step right here where we retrieve the top K documents. So the first step is essentially to set your environment variables. And this is just a generic function that will allow us to set our environment variables when we need it. So we're going to set our OpenAI keys, LangChain keys, and Hugging Face keys. So we're using OpenAI to generate the embeddings. And that's why we're using OpenAI. We're using specifically text embedding 3 small with the dimension size 256. We're using LangChain. I have a LangChain API key because I am using LangSmith for monitoring and observability of an execution. And we have Hugging Face key to just essentially access Hugging Face to load some data. So here we have the fake tech company market report, and we load it into an environment. And this data set has, for each data point, you have a fake company, Cyber Defense Dynamics. You have the ticker symbol, and you have some key metrics such as the market performance, the stock market performance of this particular company. We also have market reports for the year 2003 and 2024. They're extensive. They're extensive enough to generate a bit of to simulate what you would see in typical market reports. Then we have some recent news headlines and content. And we're going to use this as the knowledge base for either the RAG pipeline or the AI agent within our agentic system. So this is what the data set we're working with looks like. There are no embedders yet. To generate an embedding, there'll be a step here to combine the attributes of this data set that actually captures the semantics of a data point. So things like the recent news, the reports, and the recent news and the reports will actually have enough semantic information for it to be useful to be able to conduct vector search. So this step just combines those attributes into one simple attribute, into one simple column. And then we just apply the function to combine the attribute across all data points in this data set. This is just for visualization purposes of what the combined attribute looks like, but obviously it's been truncated. You could print this out and you can see what that looks like. Or you can actually go to the MongoDB Hugging Face organization to take a look at what this data set looks like. This is in this link. The notebook for this that I'm presenting here can be accessed in the GenAI Showcase repo. It's right here. I'll put a link in the chat so everyone can have access and you can follow along. And I also take a small pause here to tell you guys about the GenAI Showcase repo. Now, this is repositories built by the team over on MongoDB to essentially cover a bunch of use cases developers and people operating with this space like yourself might encounter. So we have a lot of evaluation content, RAG, a lot of notebooks covering different stacks and flavors. We also have articles that tell the stories behind these notebooks. Then we also have a bunch of agentic use cases and notebooks as well. And the stories are accompanying them as well as articles. But also we have data sets because they're free commodities within the AI space: model, compute, and data. And we're providing you with some data with embeddings for you to actually start experimenting. So you don't need to generate embeddings. All this data set have accompanying embeddings with them. Then we have general knowledge as well. We have thought leadership. We believe in thought leadership here because this space is developing so fast. We want to educate our audience, we want to educate our developers and customers. So we have content covering what is an AI stack, how do you choose the right chunking strategy or the right embedding model. So do check out this repository. I'll put the link over in the chat and give us a star and you can fork and watch the repository as well. Going back into the code, what we can see here is we've combined the attribute of all the data, of all the attributes that basically make sense to conduct vector search on. Next, what we're going to do is for each data point, we're going to generate chunks as well. So this part of the code of this notebook generates several chunks using the text embedding for a small embedding model. So we generate the chunk and then we embed the chunk using the OpenAI embedding model. And it's at this point you start exploring different chunking strategies that you might want to consider to optimize efficient recall or retrieval of documents through vector search. So that I can dive, like I said, for each process within a RAG pipeline, you can double click and dive into it. But we have in the repo I shared, there is some thought leadership material to get you thinking how to choose a chunking strategy. But now that we've generated our chunk, we have an embedding for each data point within our data set. And this allows us to conduct vector search. The next step is to create a MongoDB account or just log into your MongoDB Atlas account. Create a database called Asset Management Use Case. And you can also create a collection called Market Reports. And one important thing is you have to create a vector search index as well if you want to enable the vector search functionality within your collection that contains your embedding. So this is what a vector search definition looks like. And all of this link will help you create all of this, the database, the collection, and the vector search index. And this particular link will grab the URI you require as well. The next step is we establish a connection to our MongoDB database and we ingest our data. And this step is mainly for if you're repeating this several times, this notebook several times, you always want to start with a clean, fresh notebook. So I kept a deletion step here that just clears the collection. But the ingestion process is with MongoDB, and when you're working with Python and using the JSON schema is very simple because it's just 2 lines, right? So like I said, in MongoDB database is really built for AI application because we use the data model that your AI agents or your LLMs are used to observing. So you can insert Python dictionaries directly into a MongoDB database without going through any transformation operations or creating any pipelines for data transformations. And some of you would have seen, or you're aware of JSON mode in OpenAI, or you might have seen last week there was structured outputs functionality that was enabled by OpenAI. This just concretely shows the relevance of that JSON schema, of that key value pair data model, and how relevant it is to build an AI application. And it's very intuitive and useful to bring that to your data layer where you're thinking, how do I store information from my AI agent directly into my database? You remove the concerns of data transformations. So that is one of the key selling points of using MongoDB within this agentic system, amongst others that I'll be sharing with you today. We're almost through with the RAG pipeline. We're about to go into some of the agentic side of this webinar, but hopefully I'm sharing some good information here. And with MongoDB, we have the concept of an aggregation pipeline, which contains a bunch of operations, which we refer to as stages. Each of this stage conduct different operation on the data. And if you're coming from a machine learning background or a data engineering background, pipelines are nothing new to you. What they mean is you basically have a series of operations and processes where the input of a process is the output of another. And you can bring that mindset and thinking to the data layer, to MongoDB when you're building your AI application. And MongoDB has different query operators. Their documentations that cover them. I'm not going to go through all of them. I only go through the ones that are within the vector search functionality. But generally, these operators are used to essentially extract the relevant data based on the parameters you're sending, the parameters you're providing within this operators, essentially to extract the relevant information that you want. So here is a vector search function. And some of you will probably have used Llama Index, LangChain, or Haystack, and they abstract some of this functionality. But sometimes to have more control or to understand what's going on underneath the model is very useful to see how to build up the query, understand the query language of MongoDB. So we have a vector search function. We have a vector search function that takes a user query and a collection, and we embed the user query like I showed in the diagram earlier, the RAG pipeline. We embed the user query to conduct vector search against the embeddings within our database, which would be the embeddings that we created earlier in the RAG pipeline. We have an onset stage, which essentially removes an attribute that we don't need. So I'm removing the embedding data attribute from each of the documents that are returned because we're not going to be using it in any downstream processes. Now, the advantages of this is you're reducing the load on the database server, essentially by returning a reduced amount of information. And there is a projection stage to select certain attributes that are required and also add in the vector search score. And once you conduct this vector search result, I'm conducting vector search on the query, this particular query here, which is to select a company from the provided information that is safe to invest in for the long term and provide a reason. And it goes without saying, None of this is financial advice. So what we'll be doing is conducting a vector search query with this, a vector search with this query, the embedding of it against the embeddings we have in our documents. Now we'll go to MongoDB and see what those look like. We have the market report that we ingested the documents into. I'll zoom in there. And this is what a single data point looks like, a single document looks like. We have the recent news attributes that contains news from 2024 and 2024, essentially, all this made up fake news, essentially, literally fake news. We also have the reports that cover 2023 and 2024. Now, this is information a human might have to read through or spend hours reading through. But what we're doing here is we're making it the knowledge base of either our RAG pipeline or maybe our RAG chatbot or our AI agent to essentially reduce the time it takes for us to sift through data that we have within our database. But the key thing is we have this embedding here as well, generated using OpenAI. So that's what a data point looks like. And with that, we've conducted a vector search and we've retrieved 2 relevant documents. So that are related to this search query. So we retrieved the company Geonomics Med. We also retrieved alongside it the combined attributes as well. So this will be passed into the LLM as additional context. And this is the second company we retrieved as well with the vector search score. A vector search score typically ranges from 0 to 1. So 0.75 is relatively good. And that essentially, I'm going to stop there because that is 80% of a RAG pipeline. The rest of the steps to finish off this RAG pipeline is to take this data retrieved and just pass it alongside the user query to an LLM like GPT-4 or whatever LLM of choice you're using. And then you'll be able to get a response to the query that is essentially relevant. But let's move, we're going to use the same data set. We're going to use some of the same logic, and we're going to move into AI agents and agentic systems. And this is, we've gone through this already, but this is what essentially we'll be creating. We're going to use a bunch of libraries and a bunch of tools here, because an agentic system is a collections of multiple tools or multiple system components. And unlike a RAG pipeline where you're only concerned with maybe the chunking, your chunking strategy or your embedding model, within agentic system, there is many considerations and many aspects that you need to be thinking about. This notebook will give you a very simplistic overview that you can build upon. So today we'll be using Tavily for real-time search. And I'll be showing you how you can use Tavily as an AI agent's working memory. So the best way I try to describe working memory is like this. So I have a book here, Hidden Potential, and I try to remember the name of the author. I look at it, Adam Grant. And if you ask me again what the name of in this same conversation, what the name of the book, what the name of the author is, I'll remember Adam Grant. But it will be very how would I say, it will be a very long process if every time you ask me, I have to go look for the book and find out the name is Adam Grant. So with Tavily, what we're doing is we're doing a real-time search for information, real-time information. But with MongoDB and Tavily's integration, you can get the real-time information and place it within a MongoDB collection. So when you ask the same query in a session, you don't have to go back to look for the book or do the real-time search. You just look into your database because you have the information. But you can also mix and match. This is a concept that we're calling hybrid RAG, because you're doing 2 forms of RAG to get a more funneled output. So also to use Tavily, you have to also use Cohere as well, because they use Cohere as a re-ranker. So you need your Cohere API key. I'm using Anthropic for this particular demo, but you can use any model of your choice. I'm also using LangGraph as the as a framework for building this multi-agent system. I've mentioned MongoDB as the memory provider for agentic system, and you can let me know if that solidifies your understanding of how MongoDB, or how you can see MongoDB in the agentic space. But in this notebook, we're going to see different ways of using MongoDB to essentially augment augment an AI agent's memory. The three main form we're going to be seeing is a knowledge base, which we've already seen earlier with the RAG pipeline. So we already have an existing knowledge base, which is right here, the market report. But we're also going to be seeing active memory. I just spoke about it. And we're going to be seeing the state store. So LangGraph has the concept of state, which is a data structure that captures all interactions and operation information within the execution of the graph. So we store this in MongoDB as well. Why? Because it allows us to start a session from a previous state. So you can start a conversation from a previously stored state rather than you starting from scratch. Or you can start an execution from a previously stored process rather than starting all the way from the beginning of an execution workflow. So this is one of the reasons why you want to store the state of your graph. So there are LangGraph is widely adopted, and you can go over to LangChain and the LangGraph tutorials to get more understanding of how they're thinking about building and implementing this agentic system and the keywords that using, such as states, workflow, and graphs, and nodes as well. We'll come to that. So the first thing for a knowledge base is you need a vector store, essentially, because our knowledge base is going to essentially be retrieved through vector search. We're going to be retrieving information from our knowledge base through vector search. So we'll be using MongoDB as a vector store here. And with the LangChain integration, you can just, with a few lines, make a connection or create a vector store make a connection to your vector store, create an object that represents a connection to your vector store. So here we've just created a vector store of a market report by passing it the URI string and the collection name, and as well the embedding model that we use to embed the attributes within the documents or within the market report. We also need the index name and the text key as well. And that's it. We have a knowledge base. We can use this in any way. We can use this as a retriever or as a tool for our agent, which we're going to see in a second. But before we go any further, I want to touch on active memory, which is essentially using, making another connection to our active memory, which is also a vector store, because the active memories have embedding, the items within the active memory has embedding. So we'll be accessing our active memory, or you could call it working memory as well. We have this debate internally on the right terminology to use, but you can access your active memory and essentially create a connection to it. And this code here is extensive, but what I'm doing here is, or what's been done here is, we're creating a checkpointer, which essentially is a process to store the state within the MongoDB database. So this is the information of the execution of the graph that is being stored and created by each node within a graph. So I'll just collapse this. Next, and this is, we're starting to go into some interesting aspects of agentic system, which is how do we create tools? So with using LangGraph and LangChain, you have this tool decorator, which essentially allows you to turn a Python a function into a tool that can be passed into an agent executor within LangChain. So here I have a tool called list companies. And what this specific tool does is it goes into the knowledge base or the market report, and it lists a bunch of companies that is within a specific collection. So I've got a bunch of tools that does several different functionalities. List companies, search company. This one just searches a single company. We also have get market report by company name. So that will go into this collection and gather the report, the market report, right over here. Let's collapse this. It will gather this market report by searching on the company name. And you can give all of this database functionality, wrap it up in a Python code and use it as a tool and provide that to the agent. Essentially, you can provide it to the agent and allow the agent to decide for whatever task to then utilize the tool that you've given it access to. So if I was to go through these tools that I created, there's a number of tools here that I've just kept to just show different flavors of ways you can build, but you can actually go through this code. I've provided you the link. You could go through this yourself and understand what I'm actually doing here. But I've also provided the ability to search the internet or do a real-time search with Tavily as a tool for the agent to use. So whenever the agent doesn't find any information within its knowledge, it can go to the internet to search for that information. And we've packaged that capability as a tool. But one thing is, using Tavily, the hybrid client of Tavily, we're able to then store any real-time information into a MongoDB database or MongoDB collection, and we're calling that active memory for this agentic system. And this will be getting updated whenever the agent decides to use the tool, and it will be getting updated with any real-time information that is not present in the collection as well. So you can, this is just a functionality, and you can have different application of this functionality to different use cases. Again, we'll wrap this up using the tool decorator. We'll wrap it up as a tool. So this is the tool to search for company real-time information. I'm just going to collapse this. To really give you a true flavor of how of automation of workflows, I guess we are targeting white-collar jobs. And most of them, most jobs, white-collar jobs, have a lot to do with presentations, Google Docs, Google Sheets. So I have a collection of tools that essentially provides you with the ability to create a Google Doc and send emails. Very generic functionality that are applicable to a variety of use cases. So for our asset management analyst use case, you might generate an investment thesis or strategy. You might want to put that in a Google Doc and then send that to your manager for further review. Well, you can build this agent to essentially do that. Tell it to do some investment analysis based on its knowledge, or go to the internet and generate an investment report and actually send some stuff over. So the tool here is extensive, but generally what you have there is a bunch of tools that allows you to send emails and create Google Docs. And we've packaged that as tools for the agent. Now we go into the creating components of this agentic system. So I'm going to be using Anthropic, particularly the Claude 3 Sonnet. But very simply, you could just switch out the model and replace with any model of your choice. But we're using Claude over here. And I have this visualization that allows people to think and how to think about agents, essentially. So feel free to go through this. I'm going to be cautious of time. And with LangGraph, there are very simple steps. You create an agent, you create your state, you create your nodes, and then you create a graph and you compile the graph. So I'm creating a function here called create agent, which takes in the LLM, it takes in the tools, and it takes in a system message to essentially steer the LLM into a specific role. And once that is done, we're not going to call this function yet. Once that is done, the next step is I'm creating a toolbox. So again, I'm very simple. I try to understand things in simple ways. So agent needs tools. Let's put all the tools that agent needs into something called a toolbox. So this toolbox is just a list that contains all the tools that we've been talking about. So the Google tools, the MongoDB tools, the web search tools. And then when we call the function to create our agent, we pass it the LLM, in this case, we're using Claude, and we pass it the toolbox and say, hey, this is the tools you can use. But then we're also passing it this system message. And this is the role I want this AI agent to take. I want it to be an asset management analyst assistant. And I've given it its roles and responsibility. But more specifically, when I ask it to generate investment strategies, I want it to use this structure. I've also given it some more additional information about the tools it has access to. So I've just created my chatbot agent, and that's it. Now, with LangGraph, what you have is the ability, I've spoken about state at various points of this webinar, but what you have is the ability to capture information within the execution, within the graph when it's going through an execution process. And each of this state is appended to by each node within the graph. So a node essentially can be a tool or an AI agent. It could be a tool or an AI agent. And essentially, what you're going to have is whenever there's an execution or a visit to a node, the output will be appended into the state. So the next node or the next execution process is aware, and you can just pass the state along each node. That way you maintain execution context throughout the graph. So here is a function called agent node. So we're creating a node that will hold the actual AI agent. So we're passing the state, we're passing the agent, which we created earlier, which is a chatbot agent, and we're passing the name of the agent. That way we're able to, this agent node will return the result of its execution process or the output and the sender name as well to keep track of it. So now we're going to create the two nodes within our graph. We have the chatbot node and we have the tool node. And remember, the tool node contains a bunch of toolbox, and we're going to call it tools. And for a chatbot, we're going to call it asset management analyst, or AMA for short. I'm not really good with names. So the last step of this process is to define the workflow, the graph itself. And I tend to call it workflow because it allows me to think about real world scenarios, and then my brain can quickly see how they fit into the implementation of the agentic representation of a human workflow or a manual workflow. So before I go into like thinking about agentic system, it's always good to think about ways. It's always good to think about this human workflow, the process you're going through when you're executing a task. For example, our asset management analyst, when she wants to generate an investment strategy, she has to find out some information about the company, search to find out information. She might look to some data source or go to the internet. Then after that, she might put the research findings into a Google Docs in a specific format that the company is used to, and then send it by email to a messenger. So all of that, we've actually created tools to do all of that. But before creating, I didn't go in to create the tool first. I thought about the workflow first. And this allows you to build things more intuitively. This is just my approach, might not be the best. So here we're going to create essentially a workflow that contains a bunch of nodes. And within this workflow, we're going to have our chatbot and our two nodes. And the entry point is going to be our chatbot. So when we execute this, this node or graph, we're going to start with the chatbot. We give it a message. And based on the message it's given, it's either going to, this is a conditional edge. Based on the message it's given, it's either going to use the tools that is got available to it, or just end the execution. And that's it. It's a very simple graph. The next step is we compile our graph and then we visualize it. I've got 10 minutes left, but we will see some of this in action. So we compile our graph and we visualize it. Then the rest of this is just boiler code where we can execute our graph and essentially extract the messages from the graph. So I actually have this running and I've had it running for several minutes now. So let's hope Amma is still alive. So we can say hi. Oh yeah, she's still there. So we can ask Amma to give us some information. I'm just going to zoom in to give us some information on Apple. And I'm choosing an Apple because let's ask her, what can you do? I can't spell on live streams. So we've just asked Hammer, what can you do? And if we do go through some failures, I do have some steps that handles failure. So I have retry steps. I have some retry steps over here. So whenever there's a failure, it would retry. And I think LangGraph, you can set the amount of times for retries as well within the actual LangGraph library itself. But I've asked it, what can you do? And it's told us what it can do in different ways, what we've told it to do in the prompt. What tools do you have access to? So let's see what tools it has access to. So it's got the ability to authenticate, get document, create Google Docs, send email, search companies, and do a bunch of other things that we've specified it to do. I'm going to tell it to get me information on Apple, and let's see what it does. Let's see what tools it uses and the process. While it's going through the step, I'm going to show you another design pattern, because some of you are going to build this agentic system and you're going to have a robust set of tools. But the sort of guidance from OpenAI is to basically use around 10 to 20 tools when you're actually calling your model. So don't overload your context window with loads of tools, or you will get you will see a loss in performance or a loss in accuracy. But 10 to 20 tools can seem a bit small for large systems. So I'm going to show you another way you can use MongoDB as a toolbox. And I'll show that very quickly. We're just going to read through what Amma provided. So I asked Amma to provide some information on Apple, and it was able to get this information: when it was founded, designed, sell products. And it says, this is the step. It took some step to look at the available tools to get the Apple information. It went on to search for the company using our tools, and it couldn't find it in our database. Then what it said is it would then use the real-time search. So it used Tavily to essentially get information on Apple. And that gets stored in its active memory right over here, right into MongoDB. So we're using the web search, but then we're storing it into MongoDB, and it's connected through the Tavily MongoDB integration. So that when next you run the same query, it will go straight to the database as opposed to go to the web. I'm going to show you one last thing where I say generate an investment thesis on Apple. And this will generate a bunch of prompt. Let's see. Just need to scroll down here. And if you run this, you'll be able to generate theses or strategies. Might take a while, but then you can then send that into Google and send that into an email using the different tools. And there we go. It's generated the investment thesis. in the format that we've told it to. I want to leave some time for Q&A. But this is all the tools that this is a showcase of the tools that we've given the system to be able to access the AI agent within this agentic system to be able to access. I'm just going to tell it to create a Google Doc. And while that is, I'm going to need to go over and give it the authorization code because this is actually in beta. So it's not been approved by Google. Okay, just getting the access code. I'm gonna have to do that one more time. There we go. Let's see. I'm going to skip this step because of time. I want to show you one thing. How can you, if you have multiple tools, how can you then bypass the guidance for 10 to 20 tools by OpenAI? Fine-tuning, fine-tuning is a way to solve it, is a way to recommend it, or you could break up your tools into group. But one thing you can actually do is use MongoDB as a toolbox, where you store the JSON definition of your tools in MongoDB. So very quickly, we create a collection called tools, and we have this design pattern, which is we have a decorator design pattern that allows us to convert a Python function similar to what LangGraph is doing. We convert that into a JSON definition of a tool, then ingest that into MongoDB. So that's what this part of the code is doing. And then we conduct vector search on what we have within our database, the tools we have in our database. This is what the decorator looks like. And if you recall, with LangGraph or LangChain, you had the @ tool. With this implementation, I have something called @MongoDB toolbox. And this will take this function and store it into MongoDB. So now I have about 6 tools, but when I want to retrieve a tool for a specific query, I will not get all 6. I will just get 2, the ones that are very close, that closely match the description of the function. So that is MongoDB as a toolbox, and that is available right here in part of our tools section of the dataset, which I will provide over here as well. I'll put that into the chat. I'm going slightly over time, but if you will all forgive me. So I'll put that into the chat. Everyone can have access to this. So this is MongoDB as a toolbox. And on that note, we'll go back to finish off right here. So what we've seen here is MongoDB as a memory provider within agentic systems. We used it as a knowledge base. I've shown you MongoDB as a toolbox, a data store, and an active or working memory. So those are different flavors of memory capabilities or functionalities within a agentic system that improves the reliability, functionality, and allows you to build more robust AI applications.
Thank you so much, everyone who joined today's presentation. I know we are at time, but we can go over maybe just like 2 minutes because I know Apoorva is on and has been answering your questions throughout this presentation. So thank you so much, Apoorva, for doing so. Also, make sure you are filling out the poll before you exit today's webinar. I'm going to hand this over to Apoorva to answer maybe 1 or 2 questions.
All right. Let's see. I've answered pretty much everything that came in while the recording was going on, but let's look at this one. Can you list all the API or tools you use for this demo? Yeah, so we use MongoDB Atlas as the vector store and memory provider for the agent that Richmond was building. Then we use LangGraph to orchestrate the agent end to end. And I believe he was using OpenAI models, if I'm not wrong. But yeah, we've also been linking the notebook in the chat, so definitely check that out to get a more detailed look at the tools that were used. There's another question with a collection of questions. What type of runtime environment are you using in Google Colab? I think he was using CPU. There's no real need for GPU or TPU since we aren't really running any embedding or LLMs in the Colab environment. How do you handle slow response times from the model? And have you implemented any optimizations to improve inference speed? I don't think he specifically had, but especially if you're using like third-party providers for your LLMs, then yeah, the response times are going to be capped by your network latency and the inference provider's API latency. But if they have async support, then that's something you can explore. Have you tried integrating the model into a web application? If so, did it impact response time? We haven't done that, but I think the same limitations when it comes to network and API latency would apply there as well. But yeah, if you're building production grade applications, then you might want to do like multi-threading, asynchronous programming, that kind of stuff. What strategies do you recommend for efficiently deploying an LLM model in a production environment while maintaining low latency? So the thing that I was just mentioning, but other than that, I would say take a really good look at your architecture as well. Start with something simple, evaluate thoroughly, and only add additional components if needed. So with agents, you have to assume that there is going to be some level of latency because you're leaving all the planning, execution to the LLM. So maybe take a look at whether or not you need an agent or you can get by with something simpler. Can I integrate with one last question? Can I integrate with other agentic frameworks like Crew AI? Yeah, I think we have some notebooks in the repository that Richmond was mentioning. So definitely check that out for other agentic frameworks like Crew AI, Haystack, AutoGen. And yeah, I think that's all the questions that we have time for. If you have more, then reach out to us through our community forums, LinkedIn, YouTube, whatever.
Thank you so much, Apoorva, for staying on and answering all these questions. Thank you to our global audience for staying late or waking up early and engaging with us throughout this webinar. I'm going to drop the link that Apoorva was talking about to our community developer forum so that you can continue engagement with us there. This link will also be shared early next week with the recording and additional resources too, so you won't miss out on anything. Again, thank you all for joining today's presentation, but give me 1 second. I just dropped the link in the chat for the community forum for you all. I hope you all have a great rest of your day. And again, the presenter's name was Richmond Alake, so you can also find him on LinkedIn as well if you have any specific questions for him, or just drop those in the community forum, which we just dropped in a link in the chat, not the link. Thank you all for joining.
Thank you.